All right, so absolute value equations, okay? Do we remember what absolute value means? So like it has the absolute value. So it'd be like y equals the absolute value of x, okay? And remember, absolute value is the distance away from 0, right? So if I look at 1, the absolute value of 1 is what? 1, because it's 1 unit away from 0, right? What's the absolute value of -1? 1, right? Okay, so the parent function is the most basic function of an absolute value. So y equals the absolute value of x. So I'm going to go ahead and graph this for a second to kind of look at what it's going to look like for you. Okay. Now, if I make a table, okay, and I pick some values for x, what's the easiest number to plug into any equation? How about 0? Okay, if I plug 0 in for this, what's the absolute value of 0? 0. So we have the point of 0, 0. No matter what, every single parent function, whether it's linear or nonlinear, will always go through the origin of 0, 0. Okay? This 0, 0 is known as my vertex. Okay? So the parent function of my absolute value, the vertex will be 0, 0. Okay? Now let's plug in 1. We just did this. What's the absolute value of 1? 1. So can I graph the point 1, 1? Yeah. Let's do 2. What's the absolute value of 2? 2. So can I graph the point 2, 2? Yeah. Now let's go on the other side of 0. Let's do -1. What's the absolute value of -1? No, it is 1. Why? Because the absolute value is the distance. And isn't the distance always positive? Yeah. So we have the point of -1, 1. What if I plug in -2? Wouldn't that be +2? Yeah. So do I have the point of -2, +2? So what shape do we have on an absolute value graph? It is a V. It is a V. So the absolute value function is V-shaped. Because 1 and -1 are the same distance away from 0, right? Doesn't that make sense to you guys? Now, if I talk about symmetry, what does symmetry mean? What does symmetry mean? There's equal on both sides, right? So if we have an axis of symmetry, it is actually a vertical line. It's a vertical line that splits my parabola equally in half. And in this case, isn't it the y-axis? Yes, the axis of symmetry is the y-axis. Now, as I look at that, it's a vertical line. If it's a vertical line, remember, it was always x equals wherever it crosses the x-axis, right? Where does this vertical line cross the x-axis? At 0. So the axis of symmetry for the parent function is x equals 0. Now, in other functions, it's always the x coordinate of your vertex. Okay. Now, once again, what does domain mean? What does domain mean? The x values. Those are your x values. Now, if I think of any x value, could I plug in 100 and get a y value? Can I take the absolute value of 100? Yeah. Could I do -1,000? Can I take the absolute value of a -1,000? Yeah. Is there any number I can't plug into x that would get me a y? Fraction? Well, what's the absolute value of 1/2? 1/2, isn't it? So I can do that. So there's no number I can plug in that doesn't have an absolute value, right? So our domain is all real numbers. Okay. And for that, in interval notation is negative infinity to positive infinity. Okay, so you could either write all real numbers or negative infinity to positive infinity. Okay, so this here is known as interval notation. You will use that a lot in Algebra 2, just so you guys know. Okay. Now, the range represents the y values. If you notice, the absolute value of any number is always what type of number? Positive, right? So can my y values ever be negative? No. I can't take an absolute value of something that's going to make it negative, can I? So in this case, as long as my parabola opens upwards, my range is y is greater than or equal to 0, or your y coordinate of your vertex. Okay. You want to know interval notation? That would be 0 to positive infinity. Okay. Now we use a bracket here to show that it includes 0. Y can be 0, can't it? Yeah. Okay. So that is for your parent function. Now we can transform this, like shift it, right? Don't you guys know transformations, translations, all that kind of stuff? Where we shift left, right, we could shift it up or down, we can reflect it, right? We can turn it if we really want to. The nice thing is we don't turn anything here, okay? We will reflect, we will move left to right, okay? Now, vertex form. So if you notice from our parent function to vertex form, I put something in the middle of the absolute value and something on the outside, right? That H and K will shift my graph left and right, okay? So H and K moves it left and right, okay? The H is kind of how I remember it. The H is inside with the X. So what axis is my X? What axis is X? Is it the horizontal or the vertical? The horizontal, right? So it moves it left or right. So it moves, the H moves it left or right. And I'm always going to tell you, H always lies. H always lies. Because it's minus H, that means the opposite of H. It's lying. So when you see -3, that actually means 3 is going to be a positive. Okay? K, since it's on the outside with Y, we'll move it up or down. And K tells the truth. H lies, K tells the truth. Okay? So if I see a +3, that means it's +3, it's up 3. Okay? So my vertex is H, comma, K. So H lies, that's why it's a positive H, and K tells the truth. Okay? And my axis symmetry is X equals, and remember what I said? It was the X coordinate on my vertex. So what's the X coordinate on my vertex? H. Okay? So before we graph anything, I want to talk about this. Okay? So let's look at a problem like this. Y equals the absolute value of X minus 3 minus 4. Okay? So X, Y equals the absolute value of X minus 3 minus 4. All right, so once again, I said H always lies. So my H is actually a +3. My K always tells the truth. So my K is a -4, right? So what's my vertex here? H comma K. So 3 comma -4. So how would I graph that vertex? I would go right 3, and down 4. Let's see. Okay. And what's my axis of symmetry? X equals H. What's my H? 3. And there you go. Okay, so that's what that means when the H lies, K tells the truth. It tells you your vertex. Okay? All right. So let's go ahead and look at example 1 now. We're going to actually go ahead and graph these. Okay. Graph each function and compare the graph to the parent function. Describe the domain and range. Okay? Now, looking at this, let's go ahead and first, let's graph our parent function again. Remember, our parent function is 0, 0, 1, 1, 2, 2, right? Are you guys okay with that? And my negative 1, 1, negative 2, 2. So this here is my parent function. All right. All right. Now let's go ahead and graph here. Okay. Now when it says compare, it tells us how does it shift. Okay, but let's find our vertex. Do we have an H in here? No. So H is still just 0, right? Because we're not shifting anything. Here, let me write that parent function. All right. H is 0. But this plus 3 is my K. And what does K always do? Tells the truth. So my K is 3. Okay. So what is my vertex of my new absolute value? 0, 3. So what happened to my vertex? Since it was originally 0, 0, now it's 0, 3. So what happened? It went up 3. Up 3. So when it said compare, compare just means it goes up 3 units. Okay. Now, we can do this 2 ways. Do you guys want to make a table or do you want to count every point up 3 units? Up 3 units. Okay. So if I'm at 0, 0, I'm just going to go up 3. If I'm at 1, 1, can I just count up 3? 2, 2, up 3. And the other way, up 3, up 3. The counting only works if you shift it left, right, up, or down. That's it. Once we do other things, it won't work. And there you go. Now, what's my domain? No matter what, my domain is always all real numbers, right? Okay, so my domain is always all real numbers, right? So my domain is always all real numbers. Okay, or negative infinity to positive infinity. It doesn't matter what you do to the absolute value, the domain is always the same thing. Okay. My range. Does my graph open up or down? Up. So it's always y is greater than or equal to. Now, what changed? Our vertex changed, right? It went up 3 units. So instead of being 0, we went up 3. So this is going to be y is greater than or equal to 3. And there you go. Okay. I think it was from the wind. All right, let's look at B. So I'm going to go ahead and graph my parent function again. Are you guys okay with that? 0, 0, 1, 1, 2, 2, and then backwards. And the only reason why I do this is because if I'm just shifting left, right, up, or down, it's easy to count, isn't it? Counting's a lot easier than actually plugging in and doing the math, okay? Now, is this -2 the H or the K? Is this -2 the H or the K? Is it inside with the X or on the outside? It's on the inside, so this is my H. And what do we know about H? H always lies, so my H equals a positive 2, right? So my vertex, remember, is always H comma K. So what's my H here? 2, and do we have a K? No, so my K is still going to be 0. So how would I graph this vertex? How do I graph 2, 0? I would go right, 2, and that's it, right? So now, could I count every point right 2? Yeah, so let's count every point right 2. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And there's my new graph. What's my domain? What's my domain? All real numbers. Does that ever change? No. This should be an easy point for you. No matter what, this should always be all real numbers. Okay? And then my range, it still opens up, right? So it's going to be y is greater than or equal to, and what's my k? What's my y coordinate of my vertex? 0. So it's going to be 0. This is always your k. Okay, always your k. Any questions with this so far? Okay. Now, sometimes our graph can either get wider or more narrow. Okay. So that's our stretching, our shrinking, and our reflecting. We'll talk about that one in a second. Now, if it's a vertical stretch, okay, if it's a vertical stretch, that means my y values are getting bigger, right? So in this case, if it's a vertical stretch, my y values get larger, are bigger. And if it's a vertical stretch, it's technically a horizontal shrink. Horizontals are X, right? So our X is going to get more narrow than my original, okay? So I always think about my X's first. I think about, my vertical stretches, and then it's always the opposite for horizontal. And we'll see pictures of that here in a second. Now, to tell, okay, I'm going to go ahead and write, I have y equals a times the absolute value of X, okay? So we're going to have a number being multiplied by the absolute value of X, okay? If the A is greater than 1, so what numbers are greater than 1? 2, 3, 4, 5. Would 5 over 2 still be greater than 1? Yes, okay? If I multiply by like 2 or I multiply by 3, doesn't my y values get bigger? Yeah, so that's why that is a vertical stretch. So if the number is greater than 1, it's a vertical stretch, okay? All right, vertical shrink. That means my y values are getting smaller. What numbers do I multiply to get smaller? Wouldn't like 1/2? If I multiply by 1/2, don't my numbers get smaller? Yeah. So if my A is less than 1, but greater than 0, okay? And we look at them as positive numbers, okay? Now, if it's a reflection over the x-axis, what that means is my absolute value is going to open downwards, okay? The only time that's going to happen is when A is negative. When A is negative. So if we see y equals negative A times the absolute value of x. So we have a negative in the front, it will always open downwards, right? Because after I take the absolute value, if I multiply by A, won't it become negative? If it's negative A? Yeah, okay. All right, so let's flip that over. ahead and look at this, okay? Graph each function, all right? So real quick, before we do anything, we have it multiplying by 2, right? If we're multiplying by 2, do my y values get bigger or smaller? They get bigger, right? Y values get bigger. When you multiply by 2, they get bigger. So that will be a vertical what? Will that be a vertical stretch or vertical shrink? It will be a stretch, right? Because they're getting bigger, so doesn't it stretch your graph out vertically? But it will be a horizontal what? Shrink, okay? We always do stretch or vertical first, then we do the opposite, okay? Now let's go ahead and graph our parent function. So when it says compare, you're comparing is just saying it's a vertical stretch and horizontal shrink, okay? All right, so let's graph my parent function again. So 0, 0, 1, 1, 2, 2, -1, -2, okay? So here is my parent function. Okay, is everyone okay with that? Now, we can't just count here, can we? We actually have to do a little bit of a math. So when we have a vertical stretch and shrink, we have to make a table, okay? No matter what. So again, my vertex is going to stay 0, 0, right? Because do we move an H or K? Do we have an H or K? No. So now we're going to plug in 1, 2, -1, -2. All right. Now, if I plug in 1 here, okay, we're doing 2 times the absolute value of 1. What's the absolute value of 1? 1. 1 times 2? 2. Okay, so now we have 1, 2. Let's plug in 2. What's the absolute value of 2? 2. And what's 2 times 2? 4. So we have the 0.24 now. All right, let's do -1. What's the absolute value of -1? 1. And what's 1 times 2? 2. Do you see how these guys are symmetric? They should be, right? So what is -2 going to be? It's going to also be 4. Okay, so we have -1, 2, and we have -2, 4. And now can we draw our V? Now, do you see how it's getting vertically stretched, meaning it's getting more narrow for your horizontal shrink in that sense? Okay. Does that make sense to you guys? What's my domain? All real numbers, always. Every single person should get that problem right when I ask domain. My range, does this open up or down? This opens up, so it's y is greater than or equal to. And what's my y coordinate on my vertex? What's my k? 0. Okay, 0, isn't it? Okay. Let's look at B here. Okay, look at B. Now, I'm going to go ahead and do my parent function again. 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. And I do that because it helps compare a little bit, right? Now, we have a negative out front. So what does that negative out front mean? That it's going to open what direction? It's going to open down, okay? The negative out front will always tell me it's going to open downwards. So that means this would be a reflection. Do you know a reflection over what axis? The x-axis, okay? Now, when we multiply by 1/2, do my y values get bigger or smaller? When you multiply by 1/2, what happens to your numbers? They get smaller, right? And if they get smaller, that's going to be a vertical shrink. Good. And since it's a vertical shrink, it's a horizontal stretch. It's always the opposite. We always go based off your number for vertical, and then the horizontal's always opposite, okay? Now let's go ahead and make our table. Does my vertex change? Do I have an H or K? We do. What's inside the absolute value? Just X. There's no number in there, right? So my H is still 0. My K is still 0, right? Okay. Now, here's the question. We could still pick 1. We could still pick 2, but we're multiplying by a half, right? Can I divide 1 by 2? No, you get a half, don't you? So pick some numbers that are divisible by your denominator. What number can I divide by 2? 2 or 4. So I'll do -2 and -4. Is everyone okay with that? Okay. Let's plug in 2. So -1/2 times the absolute value of 2. What's the absolute value of 2? 2. And what's 2 times -1/2? -1. So we have 2 -1, and we have -2, -1. Aren't these always going to be symmetric? Yes. So I can graph 2, -1, -2, -1. Okay. And then let's do 4. -1/2 times the absolute value of 4. What's the absolute value of 4? 4. And what's -1/2 times 4? -2. 4, -2. -4, -2. All right, now, do you see how this is? I know it's upside down, but do you see how it's actually wider from that? So vertically it got wider, so that's a shrink. Horizontally it got wider out, so horizontally it's stretched. Okay. All right, any questions with that so far? All right, I'm going to go ahead and just do one of these ones. All right. So again, let's go ahead and graph our parent function. So our parent function is 0, 0, 1, 1, 2, 2, and then backwards, right? Now, do we have an A in this problem? No. So do we have to worry about vertical stretches or vertical shrinks or reflections? No. Okay. But we do have an H and we do have a K. What does H always do? Lie. So what's my H actually? -2. My K tells the truth, so my K is -3. So what is my vertex? -2, -3. Alphabetical order, HK. Okay. Now, for us to compare this, can you guys tell me how to graph -2, -3? How do I graph the point -2, -3? I go left 2 and down 3. This is actually comparing. When it says compare, by saying left 2, down 3, that's your comparison. Okay, so now, can we just count left 2, down 3 to every point? Yeah. So left 2, down 3. Left 2, down 3. Left 2, down 3. And then can I draw my V? Yeah, and there you go. That's it. Mm-hmm. Okay. And then B, I'm not going to do all this, but can you compare it? What's my H and B? H always lies, so that would be +3. It lies, right? So -3 means +3. And then my K tells the truth, so it would be +1. So what's my vertex? 3, 1. So how do I graph that? Right 3 and up 1. That would be your comparison. Okay. All right. And then example 4. We're going to do the exact same thing we just did up here. I just added a little bit to it. Okay. Can we handle that? Yeah, I think we can. What does the negative in the front mean? It's going to open what? Down. And if it opens down, that is known as a reflection over the x. Okay. What does the 2 tell me? That means we multiply, right? Multiply by 2. So if we multiply by 2, do my numbers get bigger or smaller? Bigger, so it's a vertical stretch. So since we multiply by 2, my y's get bigger. So it's a vertical stretch, but a horizontal shrink. Great. All right. This -1, is that my h or my k? H, so h always lies, so we know it's a positive 1. The +3 is my k, and k tells the truth, so it's a positive 3. So my vertex is 1, 3. So how do I graph 1, 3? Right 1 and up 3. So that's your comparison, guys. So when it says compare, this is what happens. We have a reflection over the x, we have a vertical stretch or horizontal shrink, and then we go right 1, up 3. Now, if I actually had to graph that, guys, you would actually have to make a table, which we're not doing that yet. A little bit ahead right now, okay? All right, B. Okay, it is the one that's I thought. Like, because my door's unlocked. Huh? Well, why don't you open my door? Would you mind just opening my door? Huh? Thanks. Now watch it slams. All right, sorry guys. The breeze actually is doing some weird things. All right, so in B, the last one here, do we have a negative in the front? No. So do we have a reflection? No. So it's opening upwards. We have no reflection. All right, now think about multiplying by 2/3. If I multiply by 2/3, do my numbers get bigger or smaller? They get smaller, right? So if they get smaller, it would be a vertical shrink. And if it's a vertical shrink, that means it's a horizontal stretch. Great. Okay. The +5 is actually my h. And what does h do? Lie. So that means it's a -5. The +6 is my k, and k tells the truth. So my vertex is -5, 6. So how do I graph -5, 6? Left 5 and up 6. And there you go. That's your comparison. That's it. That's graphing. Okay. Is that as bad as you guys thought it was? No, a little bit. That's annoying a little bit. Yeah. You hit this a lot in Algebra 2 too. Okay. So again, you have the 3.7 online. Hopefully it's open. It should be open. Okay. Tomorrow you have a quiz over 3.4 and 3.5. This is due by 2:45. I know. 2:45. I know. Look at you going. Okay. And then your 3.7, every makeup work, obviously all your homework should be due by tomorrow, except for 3.7. Okay. 3.7 will be on your test. You won't quiz on it next week. Okay. You're just testing next week. Okay. All right. I'm going to go ahead and stop recording.